Welcome to Sleepy Earth Channel. Tonight, we're traveling back to a time when Antarctica was not covered in endless ice, but filled with ancient forests, giant creatures, and mysterious oceans hidden beneath strange polar skies. Together, we'll explore the lost world that existed before the cold swallowed everything. So get comfortable, relax, and before we begin, leave a comment below telling me what city you're watching from tonight. There was a time when Antarctica did not belong to ice. Long before the continent became the coldest place on Earth, before storms buried entire mountain ranges beneath kilometers of frozen silence, the bottom of the world was alive. Not with a few scattered patches of moss clinging to rock the way it survives today, but with forests, rivers, thick wetlands, creatures moving beneath towering trees while the sky above them glowed for months without darkness. If someone could stand there more than 90 million years ago, the landscape would feel almost impossible to recognize. There would be no endless white horizon, no frozen deserts, no empty wind screaming across the ice sheet. Instead, there may have been dense green valleys covered in ancient conifers and giant ferns, their leaves dripping beneath warm rain, while insects buzzed through humid air that barely resembled the Antarctica we know now. And the strangest part is that this world existed near the South Pole. Even now, that detail feels wrong somehow. Human instincts associate polar regions with cold and death so strongly that it becomes difficult to imagine forests thriving in a place where modern temperatures can fall below -80 degrees Celsius. Yet, the geological evidence left behind inside Antarctic rock tells a very different story. Fossilized tree roots have been discovered deep beneath the ice. Ancient pollen grains still survive in sediments that were once mud at the bottom of forgotten rivers. Scientists have uncovered traces of forests so extensive that some researchers believe Antarctica may once have looked vaguely similar to parts of modern New Zealand, Patagonia, or the Pacific Northwest during warmer climatic periods. The further researchers dig into the continent's past, the more Antarctica begins to resemble not an icy wasteland, but a lost world erased slowly enough for entire ecosystems to evolve, flourish, and disappear almost unnoticed across millions of years. One of the reasons this ancient Antarctica existed at all was because Earth itself was different. During the age of dinosaurs, especially through large parts of the Cretaceous period, global temperatures were dramatically warmer than today. Atmospheric carbon dioxide levels were far higher, trapping heat across the planet. There were no permanent polar ice caps. Sea levels stood hundreds of feet above modern coastlines, drowning entire regions that are now dry land. Tropical forests expanded farther north and south than modern ecosystems allow. Even the oceans behaved differently, carrying warmth toward the poles in ways that modern currents no longer do. Antarctica was not isolated yet. It remained connected to other southern land masses through the remains of Gondwana, the enormous supercontinent that once joined South America, Africa, India, Australia, and Antarctica together into one vast southern world. Because of that connection, warm ocean circulation could still reach Antarctica more effectively. Forests spread across the continent over immense stretches of time, adapting to conditions that sound almost contradictory. Warm temperatures existed alongside months of darkness. Summers near the pole brought long periods of constant daylight, while winters plunged the continent into extended night. And somehow, life adapted anyway. That adaptation may be one of the most fascinating parts of Antarctica's forgotten history. Even in a greenhouse world, polar darkness still existed. Dinosaurs, plants, and entire ecosystems had to survive months where the sun barely rose above the horizon or disappeared entirely. Scientists still debate exactly how these forests endured such conditions. Some ancient trees appear to have grown extremely fast during the bright summers, storing enough energy to survive the dark winters. Fossil growth rings inside Antarctic wood suggest seasonal stress patterns similar to modern trees living in high latitudes. But unlike modern polar forests, Antarctica's ancient ecosystems operated in temperatures far warmer than anything near the South Pole today. In some regions, annual temperatures may have stayed above freezing for most of the year. Rainfall likely fed wetlands and river systems stretching through valleys now buried beneath ice sheets thicker than skyscrapers are tall. There is something deeply unsettling about imagining that hidden world still trapped beneath modern Antarctica, because, in a way, it still exists. Under the ice today are mountain ranges no human eye has ever fully seen. Ancient riverbeds remain buried beneath glaciers. Sediments from vanished forests lie compressed under millions of years of geological pressure. Radar scans occasionally reveal landscapes so intact they resemble entire continents frozen mid-transformation. Antarctica sometimes feels less like a continent and more like a sealed archive of Earth's older realities. And unlike lost civilizations buried by sand or jungle, Antarctica preserves its past beneath ice so cold that biological traces can survive for extraordinary lengths of time. In some places, scientists have drilled deep enough to uncover pollen from forests that vanished tens of millions of years ago. That pollen alone changes the emotional weight of Antarctica completely, because pollen means wind, soil, seasons, flowering plants. It means there were once ecosystems here complex enough to support cycles of reproduction and migration across enormous spans of land. Some researchers even suggest Antarctica may have once supported forests dense enough to influence global climate patterns themselves. The continent was not merely surviving warmth, it was part of the machinery creating it. And yet, even during these warmer ages, Antarctica was never entirely comfortable. The farther south life expanded, the stranger the environment became. Imagine forests growing beneath a sun that refuses to set for weeks. Imagine rivers reflecting orange midnight light, while dinosaurs move through fog-covered valleys at what should be 2 a.m. Then imagine the opposite season arriving, when darkness slowly consumes the continent for months. Survival in such a world would not simply require strength, it would require biological flexibility unlike almost anything alive today. Some paleontologists suspect many Antarctic animals may have possessed adaptations closer to birds or mammals than classic reptilian stereotypes suggest. Evidence increasingly points toward at least some dinosaurs being active, fast-moving creatures with higher metabolisms than earlier generations of scientists believed. Antarctica may have helped reveal that possibility because cold, seasonal environments place enormous pressure on slow-moving, cold-blooded life. In other words, the very existence of dinosaurs near the South Pole forces scientists to reconsider what dinosaurs truly were. Ancient Antarctica does not only change the continent's story, it changes the dinosaur story too. And perhaps the most haunting detail is how normal this lost world may have seemed while it existed. There was no dramatic moment where Antarctica suddenly froze overnight. No single catastrophe instantly transformed forests into ice. The continent drifted slowly toward isolation across millions of years. Ocean currents shifted. Atmospheric chemistry evolved. Temperatures gradually declined. Forests retreated, step by step. Species disappeared, one generation at a time, until, eventually, the entire southern world became trapped beneath permanent ice. If intelligent observers had lived there through those ages, they might not even notice the transformation happening around them. A river freezes slightly earlier each winter. Certain trees stop growing in colder valleys. Migratory patterns shift. Wetlands shrink. Seasons become harsher. Over enough time, an entire ecosystem vanishes without any creature fully realizing it is witnessing the end of its world. That gradual disappearance gives Antarctica's history a strange emotional weight. Most ancient extinctions are imagined as violent. Asteroids, volcanoes, firestorms. But Antarctica's transformation was quieter, more patient. A slow geological suffocation stretched across epochs. And because the process happened so gradually, Antarctica became a kind of biological time capsule, preserving multiple worlds layered on top of each other. Beneath modern ice may rest the remains of ecosystems separated by millions upon millions of years. Entire climates buried beneath newer climates. Entire forests entombed beneath younger ice. The deeper scientists investigate Antarctica, the less permanent Earth itself begins to feel. Continents drift. Oceans change direction. Tropical worlds become frozen deserts. And places humans instinctively view as eternal may only represent temporary phases in a much longer planetary cycle. Antarctica today feels ancient because ice creates the illusion of permanence. But in geological terms, frozen Antarctica is relatively new. The green Antarctica before it lasted for enormous stretches of time, far longer than human civilization has existed, far longer than recorded history itself, which raises an unsettling possibility. If Antarctica could transform this completely once before, then perhaps no environment on Earth is truly fixed forever. And buried somewhere beneath the silent ice of the southern continent beneath mountains no sunlight has touched in millions of years, the remains of those forgotten forests still wait in darkness, like memories the planet never fully erased. The forests of ancient Antarctica did not grow beneath an ordinary sky. Even during the warmest ages of the continent's past, the land still sat close enough to the South Pole to experience one of the strangest light cycles on Earth. For part of the year, the sun simply refused to disappear. Daylight stretched endlessly across the horizon in a slow, golden circle, turning midnight into something dim and dreamlike instead of dark. Shadows became weak and directionless. Time itself may have felt distorted there. Animals could move through the forest at what should have been midnight, while the sky still glowed with cold amber light filtering through thick clouds and towering conifers. Modern humans are not built for that kind of environment psychologically. Even now, people living near polar regions often describe losing their sense of time during months of endless daylight. Sleep patterns collapse. Hours blur together. Ancient Antarctica was not only biologically unusual, it may have felt emotionally strange in ways difficult to imagine today. And yet, life adapted so completely that entire ecosystems flourished there for millions of years. The forests themselves were unlike modern tropical jungles, but they were far from barren. Much of the vegetation likely resembled dense temperate rainforest mixed with ancient plant lineages that no longer dominate Earth today. Giant conifers rose above thick undergrowth of ferns, mosses, horsetails, and early flowering plants. Some trees may have looked vaguely familiar to modern Southern Hemisphere species found in Chile, New Zealand, or Australia. Remnants of evolutionary families that once stretched across Gondwana before the continents drifted apart. Fossil evidence suggests Antarctica supported forests capable of growing surprisingly large despite the polar conditions. Tree trunks discovered in Antarctic rock reveal growth rings showing years of sustained development rather than stunted survival. Rivers carved through valleys carrying nutrients into wetlands crowded with vegetation. Insects moved through the canopy. Small animals likely nested among roots and swampy riverbanks. The image many people have of Antarctica as eternally silent and lifeless completely collapses when confronted with this older world. In some seasons, the continent may have sounded alive almost constantly. Wind through conifers, rain striking broad fern leaves, insects humming beneath endless twilight skies, water moving through dark rivers reflecting sunlight at impossible hours. There is a temptation to imagine these forests as peaceful because they are ancient, but ancient ecosystems were rarely peaceful for long. Even in warm climates, survival near the poles created pressures unlike almost anywhere else on Earth. The biggest challenge was not necessarily cold, it was darkness. Months of limited sunlight created a problem every plant had to solve. Modern forests depend heavily on stable day-night cycles. Ancient Antarctic forests did not have that luxury. During long polar winters, sunlight weakened dramatically or vanished altogether, depending on latitude. Scientists still debate how productive these ecosystems truly remained during those periods. Some researchers believe many plants entered forms of seasonal dormancy similar to modern deciduous forests. Others suspect the relatively warm greenhouse climate may have reduced winter severity enough for some vegetation to continue limited growth despite darkness. There are even theories suggesting ancient cloud cover and atmospheric conditions scattered light differently across polar regions than they do today, though evidence remains incomplete. What makes the mystery fascinating is that no modern ecosystem perfectly matches ancient Antarctica. There is no exact comparison anywhere on Earth today. It was a world operating under rules partially familiar and partially alien. Even the forests themselves may have behaved differently than modern forests because atmospheric carbon dioxide concentrations were far higher. Some prehistoric plants likely grew faster, larger, or more aggressively than modern descendants under those conditions. And because Antarctica experienced extended periods of uninterrupted summer sunlight, certain plants may have used those endless days to grow at astonishing seasonal rates before winter darkness returned. Fossilized wood from Antarctica sometimes reveals unusually wide growth rings, suggesting periods of rapid expansion that transformed the landscape during warmer months. In a sense, the continent may have lived in extremes. Explosive summers followed by long fading winters where the entire forest entered a slower, quieter state. That cycle would shape everything living there. It shaped migration patterns, feeding behaviors, reproduction, hunting. Even the appearance of the forest itself likely changed dramatically across the year. During peak summer, parts of Antarctica may have looked lush enough to resemble northern rainforests. Then, months later, the same valleys could become dim, cold landscapes covered in frost beneath endless darkness. One of the strangest details about these forests is how they challenge assumptions about where complex ecosystems can exist. People often imagine biodiversity thriving near the equator, while polar regions remain biologically poor. Ancient Antarctica suggests the planet does not always follow modern patterns. Warm global climates expanded habitable zones far beyond their present limits. Forests reached into regions now viewed as permanently hostile to life. And because Antarctica remained isolated by distance even before ice trapped it fully, evolution there may have followed unique directions. Some paleobotanists suspect certain Antarctic plant communities developed highly specialized survival strategies that disappeared entirely once the continent froze. Entire ecological experiments may have existed there temporarily before vanishing from Earth forever. That possibility gives Antarctica an almost mythological quality. It feels less like a normal continent and more like a hidden chapter of Earth's evolutionary imagination. And beneath the forests themselves, the ground was changing too. Antarctica during these ages was not geologically quiet. Volcanic activity affected parts of the continent periodically, reshaping landscapes and enriching soils. Rivers flooded valleys with sediment. Swamps expanded and collapsed over enormous timescales. In some regions, dense vegetation slowly accumulated into thick organic layers that may eventually have become coal deposits buried beneath younger rock. The forests were not static environments preserved in perfection. They were dynamic systems constantly rebuilding themselves. Trees died. Floodplains shifted Fires may occasionally have swept through drier areas, although evidence remains debated for certain periods. The continent was alive in the geological sense as much as the biological one. Even the sky above Antarctica may have looked different than modern skies. Atmospheric composition during greenhouse Earth periods likely created softer temperature gradients between the poles and equator. Storm systems moved differently. Some climate models suggest polar regions experienced heavy rainfall rather than snowfall for enormous stretches of time. Imagine standing inside one of these forests during a warm Antarctic rainstorm, beneath towering conifers, while distant thunder rolled across valleys now buried under miles of ice. That image feels almost impossible because the modern continent has erased all visual memory of it. There are no surviving forests there now to hint at what once existed. Only fossils remain. Fragments of wood locked in stone. Pollen trapped in sediments. Leaves pressed into ancient rock layers. Antarctica keeps its past buried carefully. Every discovery emerges slowly and often accidentally, usually from regions where ice temporarily exposes deeper geological layers before snow covers them again. Some of the most important fossil sites on the continent are only accessible during short windows of relative weather stability, and even then, researchers work in conditions so brutal that excavations become dangerous. In a strange way, Antarctica still resists being understood. The continent hides its history behind cold, the same way deserts hide ruins beneath sand. And the deeper scientists investigate those forests, the stranger the implications become. Because forests do not exist alone. Forests support food chains. Insects, herbivores, predators, scavengers, fungi, rivers filled with microscopic life. Every tree implies an entire surrounding world operating beside it. Ancient Antarctica was not merely a continent with trees. It was a functioning ecosystem, complex enough to sustain large animals through extreme seasonal cycles. That realization changes the emotional scale of the story completely. This was not a temporary warm period where a few hardy plants survived near the poles. It was a thriving world, stable enough for life to evolve into specialized forms over immense stretches of time. And perhaps the most haunting part is that much of it remains invisible. Modern Antarctica still hides enormous areas beneath ice sheets over 2 miles thick in some places. Entire mountain ranges remained undiscovered until radar technology mapped them beneath the surface. Subglacial lakes, larger than some American states, remain sealed in darkness under the ice. It becomes difficult not to wonder what else remains hidden there. Fossil forests have already been discovered near the edges of exposed regions. What lies deeper beneath the ice, where no drilling has yet reached? Could entire ecosystems remain preserved in fragments beneath frozen sediment layers? Some scientists remain cautious about overstating such possibilities, and rightly so. But Antarctica consistently reveals that its history is far more complicated than earlier generations imagined. The continent has a habit of making old assumptions collapse, and somewhere Within those vanished forests, beneath the endless polar sun, something else was moving through the trees. Because these ecosystems did not belong only to plants, hidden among the rivers and fern-covered valleys were predators adapting to the strangest forests on Earth, creatures surviving at the edge of darkness in a land where summer daylight never ended and winter threatened to swallow the world whole. Long before Antarctica became a frozen continent sealed beneath storms and silence, something enormous moved through its forests. Not in deserts baked by sunlight the way dinosaurs are usually imagined, but beneath towering conifers and endless polar skies where daylight could linger for months without true night. The idea sounds almost unnatural at first. Dinosaurs and Antarctica seem like creatures from completely different worlds, separated by impossibly incompatible climates. Yet scattered across exposed Antarctic rock, paleontologists have uncovered fossil evidence proving that dinosaurs once survived at the very bottom of the Earth. Bones, teeth, footprints, fragments of ancient skeletons trapped inside mountains now surrounded by ice fields and lethal winds. Every discovery forces the same unsettling realization. Some dinosaurs did not merely tolerate polar conditions, they evolved within them. One of the most famous discoveries came from a predator now known as Cryolophosaurus, a large theropod that lived in Antarctica roughly 190 million years ago during the early Jurassic period. Its name translates loosely to frozen crested lizard, though the animal itself lived long before Antarctica froze. The creature measured perhaps 20 feet long and carried a strange crest across its head, unlike most predators known from that era. Even today, Cryolophosaurus feels mysterious because the fossil remains are incomplete, leaving scientists debating aspects of its appearance and behavior. But what matters most is not simply that this predator existed, it is where it existed. Antarctica during the Jurassic was still forested and comparatively mild, but it remained far enough south to experience prolonged winter darkness. That detail changes the emotional atmosphere completely. Imagine a large carnivorous dinosaur moving silently through dim polar forests beneath weeks of fading twilight, frost gathering across fern-covered ground, while rivers darken beneath a low gray sky that never fully becomes day. This was not the tropical dinosaur world shown in most movies. Antarctic dinosaurs lived inside something stranger, and perhaps more difficult. The farther scientists investigate these ecosystems, the more Antarctica appears to have been one of the harshest dinosaur habitats on Earth, despite its warmer climate. Summer may have brought lush vegetation and endless daylight, but winter still created enormous survival pressures. Food availability shifted seasonally. Temperatures dropped significantly during darker months, even if they remained far warmer than modern Antarctica. Young animals especially would have struggled during periods of limited resources, which raises one of the biggest mysteries surrounding Antarctic dinosaurs. How exactly did they survive the polar winter? Scientists still argue over the answer. Some believe many species migrated northward seasonally, following vegetation and more stable climates, before returning south during warmer months. Others argue that at least certain dinosaurs stayed year-round, adapting biologically to seasonal darkness the same way Arctic mammals and birds survive today. Fossil evidence increasingly supports the idea that at least some dinosaurs may have possessed faster metabolisms and more active physiology than older reptilian stereotypes suggested. Antarctica became one of the strongest arguments against the old image of dinosaurs as sluggish, cold-blooded giants barely capable of functioning outside tropical heat. Large, active predators hunting near the polar circle imply creatures capable of sustained energy and complex adaptation. In a strange way, Antarctica helped transform how humans understand dinosaurs themselves. Before these discoveries, many people imagined dinosaur evolution occurring mostly inside warm, stable environments. Antarctic fossils revealed that dinosaur ecosystems could thrive in places shaped by seasonal stress, darkness, and fluctuating conditions. Some researchers even speculate certain polar dinosaurs may have developed feathers or insulating body coverings, particularly smaller species vulnerable to colder winters. Direct evidence remains limited from many Antarctic species, but discoveries from related dinosaurs elsewhere increasingly support the possibility. If true, parts of ancient Antarctica may have looked even stranger than most reconstructions suggest. Forests filled with feathered animals moving through fog and low sunlight beneath endless summer skies. And those forests contained more than predators. Fossil evidence points toward entire communities of herbivorous dinosaurs living there as well. Long-necked sauropods may have wandered floodplains during earlier periods, while later ecosystems included armored dinosaurs, small plant-eaters, and duck-billed relatives adapted to high-latitude life. Some fossilized juvenile remains discovered in polar regions elsewhere suggest certain dinosaurs may even have nested near the poles rather than migrating away entirely. That possibility changes the picture dramatically, because nesting means permanence. It means generations born and raised inside polar environments. It means Antarctica was not merely visited by dinosaurs occasionally. For some species, it may have been home. The emotional weight of that idea becomes stronger when imagining young dinosaurs experiencing their first polar winter. Entire ecosystems slowing beneath months of fading light while temperatures fall across swampy forests and river valleys. Survival would depend on memory, migration routes, fat reserves, food access, and social behavior in ways scientists are only beginning to understand. Some paleontologists suspect herd behavior became especially important in these environments, allowing animals to move collectively between feeding grounds as seasons shifted. Others suggest certain species may have reduced activity levels during darker months, entering states not exactly like mammalian hibernation, but perhaps involving metabolic slowing or altered behavior. There is no full scientific consensus yet, because Antarctica keeps most of its secrets buried. Fossils there are rare, fragmented, and difficult to recover. Every discovery emerges from brutal conditions where researchers work against freezing temperatures, violent winds, and narrow excavation windows. The continent almost seems unwilling to reveal its past completely. Even so, enough evidence has surfaced to reveal a dinosaur world fundamentally different from the familiar image of endless tropical jungles. Antarctic forests were dimmer, wetter, more seasonal, sometimes colder. The sunlight itself behaved strangely there, especially during transitional seasons when dawn and dusk could stretch endlessly near the horizon. Predators hunting under those conditions may have relied heavily on movement, sound, and scent through dense forests filled with mist and low-angle light. Rivers and wetlands likely became crucial pathways for survival, concentrating both prey and predators into narrow ecological corridors during difficult seasons. And unlike modern Antarctica, these ecosystems were not isolated by permanent ice. Dinosaurs and other animals could still move between Antarctica and connected southern continents through remaining Gondwanan land bridges during parts of this era. That connection matters because it allowed Antarctica to become not merely a biological dead end, but part of a larger southern evolutionary network stretching across prehistoric South America and Australia. Some Antarctic species likely shared ancestors with animals living thousands of miles away in forests now separated by oceans. In other words, Antarctica was once integrated into a living world system far larger than itself. That realization makes the continent's later isolation feel even more tragic, because eventually, everything changed. But during the height of these ancient ecosystems, Antarctica may have supported one of the most unusual dinosaur habitats on Earth, precisely because it balanced life on the edge of environmental extremes. Too far north, conditions became more stable. Too far south, survival became impossible. Antarctica existed in that narrow middle zone where evolution experimented with solutions unlike anything modern humans have ever witnessed directly. Some dinosaurs adapted, others vanished. Entire food chains rose and collapsed across millions of years, while the continent slowly drifted toward colder futures. And because these transformations happened gradually, no creature living there could fully understand the scale of what was coming. Generations of animals would simply experience winters growing harsher across evolutionary time, forest boundaries retreating slightly farther north, seasonal darkness lingering longer, wetlands freezing more deeply each year. The beginning of Antarctica's death as a green world did not arrive dramatically. It began quietly, inside ecosystems already struggling against the limits of polar survival. That may be why Antarctic dinosaurs feel so haunting compared to many other prehistoric animals. They were not creatures living in stable paradise. They survived inside a world already carrying the first distant signals of collapse. Some species disappeared entirely without leaving enough fossils for humans to even know they existed. Others evolved temporarily before extinction erased nearly every trace of their lives except fragments buried beneath ice-covered mountains. Modern Antarctica still hides most of this story. Vast areas remain unexplored beneath permanent ice sheets. Entire fossil beds may still wait below glaciers where no excavation has ever reached. Scientists occasionally discover bones exposed temporarily by erosion or shifting ice, only for storms to reclaim the landscape again. Antarctica reveals its history in flashes. A jawbone here, a footprint there, enough to prove incredible worlds existed. but rarely enough to make the picture feel complete. And perhaps that incompleteness is what makes the continent so compelling. Antarctica does not simply preserve the past, it preserves uncertainty. Every fossil discovered there hints at ecosystems more complicated than expected, climates more unstable than assumed, and creatures far more adaptable than earlier generations believed possible. Somewhere in those vanished forests beneath the polar light, predators once moved silently between giant trees, while rivers carried the reflections of a sun that barely set. And beyond those forests, along ancient coastlines and dark southern seas, even larger creatures waded in waters that would one day become the coldest oceans on Earth. Far beyond the forests and river valleys of ancient Antarctica, another world stretched outward into darkness. A world far larger, far older, and in many ways far more dangerous than anything moving beneath the trees on land. The southern oceans surrounding prehistoric Antarctica were not frozen wastelands yet. They were alive with massive predators, drifting ecosystems, deep volcanic trenches, and creatures so strange that many would seem almost alien compared to modern marine life. If someone could descend beneath the surface of those waters during the late Cretaceous period, they would not enter an empty polar sea. They would enter one of the most crowded hunting grounds on Earth. The ocean itself was warmer then, though warm can be misleading. Ancient southern waters were not tropical paradise seas glowing turquoise beneath calm skies. They likely carried a colder, darker mood, even during greenhouse periods, especially farther south, where sunlight behaved strangely near the polar circle. Fog may have drifted constantly above parts of the ocean. Storm systems rolled through massive distances, uninterrupted by ice sheets. Sunlight often reached the sea at low angles, creating dim silver reflections across dark water that could stretch endlessly beneath overcast skies. And below that surface, giant predators moved through underwater forests of plankton, fish, ammonites, and reptiles in ecosystems that modern Earth no longer possesses. One of the most feared animals in those waters was likely the mosasaur, a massive marine reptile related more closely to monitor lizards and snakes than to dinosaurs. Some species grew over 40 feet long, becoming apex predators of the late Cretaceous oceans. Fossils discovered in Antarctica suggest mosasaurs reached southern polar seas despite the environmental extremes. That detail alone says something profound about prehistoric Antarctica. These were not isolated shallow ecosystems supporting only a few specialized survivors. The southern oceans were connected enough, productive enough, and biologically rich enough to support giant marine predators at the very top of the food chain. Mosasaurs likely hunted enormous fish, squid-like cephalopods, marine birds, and possibly even other marine reptiles. Their jaws carried rows of backward curving teeth, built for gripping slippery prey in violent underwater struggles. Some species may have hunted near the surface, while others explored deeper waters where sunlight faded into cold darkness. And unlike sharks, mosasaurs breathed air, which means these giant predators regularly surfaced beneath Antarctic skies. rising through black water into endless twilight, where polar light lingered strangely across the horizon. There is something deeply cinematic about imagining those moments. A silent sea, dim orange light near midnight. Then suddenly the surface breaks as a massive reptilian predator exhales into cold air before disappearing beneath the water again. But mosasaurs were not alone. The southern oceans also held plesiosaurs, creatures whose appearance still feels almost dreamlike today. Long-necked species moved through the water with 4 powerful flippers, their bodies gliding more like underwater flight than conventional swimming. Some scientists believe certain plesiosaurs hunted fish and smaller prey near the surface, while others may have targeted larger animals in deeper waters. Their exact behavior remains debated because soft tissue rarely fossilizes well enough to reveal movement patterns completely. But their fossils appear across ancient southern marine deposits, proving these animals adapted to Antarctic waters as well. And in some ways, plesiosaurs fit the emotional atmosphere of prehistoric Antarctica perfectly. They feel ancient, even compared to other ancient animals. Quiet, elusive, almost ghost-like. It becomes easy to imagine them drifting through fog-covered seas beneath skies where daylight never fully disappeared. The oceans themselves were structured differently too. Modern Antarctica is surrounded by brutally cold currents that isolate the continent climatically and biologically. Ancient southern oceans had not yet become fully locked into that frozen system. Warm currents still moved farther south than they do today, allowing marine ecosystems to flourish at latitudes now hostile to most large marine reptiles. But those waters may still have carried unusual seasonal patterns. Long summer daylight likely fueled enormous plankton blooms, creating explosions of marine productivity during warmer months. Entire food chains would intensify during those periods as fish populations surged and predators followed them southward. Then, winter darkness returned. The surface cooled, storms intensified, food availability shifted again. Even marine life near Antarctica had to survive a world shaped by extremes of light and season. Some scientists suspect migration patterns became critical for many large marine species. Certain predators may have traveled immense distances through southern oceans, following prey and temperature zones. Others perhaps remained year-round in polar waters, adapting biologically to colder seasonal conditions, much the way whales and seals do today. Evidence remains incomplete because Antarctica preserves marine fossils unevenly, but each discovery reveals a southern ecosystem far more dynamic than earlier generations imagined. The deeper paleontologists explore Antarctic marine sediments, the clearer it becomes that these waters supported entire evolutionary dramas now mostly erased from Earth. Giant ammonites drifted through the seas in spiraled shells that resembled living sculptures. Some species reached astonishing sizes before vanishing entirely during extinction events. Schools of ancient fish filled the middle layers of the ocean, while squid-like cephalopods hunted in darker depths. Early seabirds and flying reptiles may have skimmed above the surface, searching for prey near coastlines crowded with marine life. And somewhere below them all, deeper than sunlight could easily reach, the ocean floor itself remained active. Volcanic ridges, hydrothermal systems, and tectonic instability shaped Antarctic marine environments continuously. In some regions, underwater volcanic activity may have warmed local ecosystems while releasing minerals into the surrounding sea. Ancient Antarctica was not environmentally stable in the way people often imagine prehistoric worlds. It was shifting constantly beneath the surface. Coastlines changed. Sea levels rose and fell. Ecosystems expanded and collapsed over millions of years. Some marine basins disappeared entirely beneath geological transformation. Others deepened into isolated environments where species evolved separately from the rest of the world. That isolation may explain why Antarctica still feels scientifically mysterious today. The continent sits at the intersection of multiple ancient worlds, layered across deep time. Marine fossils discovered there sometimes resemble species from South America, Australia, or New Zealand, reflecting Antarctica's earlier connection within Gondwana. But other discoveries appear strangely unique or difficult to classify, hinting at ecosystems shaped by prolonged separation and unusual environmental pressures. In that sense, ancient Antarctic oceans may have functioned almost like evolutionary laboratories operating near the edge of survivable conditions. One particularly haunting aspect of these prehistoric seas is how little direct evidence survives compared to how enormous the ecosystems must have been. Oceans preserve fossils unevenly. Entire species may disappear from history simply because their remains never settled into conditions suitable for fossilization. Soft-bodied animals especially vanish almost completely unless extraordinary preservation occurs, which means the creatures humans know from Antarctic marine fossils likely represent only fragments of a much larger reality. Some paleontologists suspect entire food webs remain essentially invisible to science because the fossil record captures only scattered snapshots. The Southern Ocean may have held predators never discovered, migration systems no longer traceable, and ecological relationships permanently erased by time and tectonic destruction. Antarctica amplifies that uncertainty because so much of the continent remains inaccessible beneath ice. Even now, scientists continue uncovering marine fossils in regions once assumed biologically insignificant. Each new discovery tends to complicate the picture rather than simplify it. The southern seas were not marginal ecosystems clinging weakly to life near the poles. They were major biological theaters filled with competition, adaptation, and predation across enormous spans of time. And yet, hidden inside that thriving world, the first signs of collapse had already begun. Slowly, almost invisibly at first, Antarctica drifted toward isolation. Continental movement altered ocean circulation. Temperature gradients changed. The currents carrying warmth southward weakened over millions of years. Marine ecosystems that depended on stable conditions faced growing stress. Certain species disappeared from Antarctic waters long before the continent fully froze. Others adapted temporarily before vanishing later. The transformation happened so gradually that no single creature would experience it as catastrophe. A predator born into one generation of ocean might never realize the waters had once been warmer, richer, or more crowded with life. But over deep geological time, the southern seas were changing direction. The oceans around Antarctica were becoming colder, darker, more isolated. And eventually, the waters once filled with giant marine reptiles and drifting ammonites would become among the coldest and most violent on Earth. But during their peak, those prehistoric Antarctic oceans may have been one of the strangest environments the planet ever produced. A place where giant predators surfaced beneath endless polar twilight, while unseen creatures moved through black water below them, and where entire marine worlds flourished in seas that modern humans would barely recognize as Antarctica at all. The end of Antarctica's ancient world did not begin with violence. There was no single impact crater, no sudden wall of ice sweeping across the continent overnight, no dramatic extinction event visible from space. Instead, the death of warm Antarctica unfolded so slowly that for millions of years, almost nothing living there would have understood what was happening. Forests still stood. Rivers still moved through valleys. Marine reptiles still hunted in the southern seas. But underneath all of it, the planet itself had already begun rearranging the rules. Antarctica's destruction started deep below the surface of the Earth, where continents drift not at the speed of storms, but at the speed of fingernails growing. For most of its ancient history, Antarctica had remained connected to other southern lands through the final remnants of Gondwana. South America, Australia, and Antarctica were once part of the same enormous world. Warm ocean currents could still move through those connected systems, carrying heat southward and helping stabilize the climate near the poles. As long as Antarctica remained partially connected to those continents, complete freezing became difficult. The southern world still breathed together, but tectonic isolation changes climates in ways almost impossible to notice within a single lifetime. Continents drift apart silently. Oceans widen inch by inch. Currents redirect themselves over millions of years, and eventually, Antarctica began separating from the rest of the planet. One of the most important turning points may have occurred when Antarctica and South America finally drifted far enough apart to open the Drake Passage, the stretch of ocean now lying between the two continents. Scientists still debate the exact timing and complexity of this transition, but many researchers believe the opening of Southern Ocean gateways allowed a powerful circumpolar current to fully form around Antarctica. That current changed everything. Today, it is known as the Antarctic Circumpolar Current, the largest ocean current on Earth. It circles the continent endlessly, like a cold, rotating wall of water, isolating Antarctica thermally from warmer northern oceans. Once that system strengthened, warm water could no longer reach the continent efficiently. Antarctica became trapped inside its own cold. The transformation sounds almost abstract at first, a shift in ocean circulation, but its consequences reshaped an entire world. Temperatures slowly declined. Seasonal snow survived longer. Winters deepened. Rain increasingly turned to ice. Forest ecosystems that had adapted to strange polar light now faced an entirely different threat: growing cold that no longer disappeared fully during summer. The process was uneven and stretched across immense spans of time. Some regions cooled faster than others. Certain valleys may have remained relatively forested long after nearby ecosystems collapsed. Antarctica did not freeze all at once. It fragmented climatically first. The continent became a patchwork of shrinking survivable zones surrounded by increasingly hostile conditions. That slow collapse may actually make the story more unsettling than sudden catastrophe. Imagine generations of forests experiencing subtle environmental decline over millions of years. Growing seasons shorten slightly. Frost arrives earlier. River systems freeze more often. Certain insects disappear from regions where they once thrived. Tree lines retreat toward lower elevations. Wetlands become colder and less stable. Entire ecosystems slowly lose complexity without any single dramatic moment announcing the end. Some paleoclimate evidence suggests atmospheric carbon dioxide levels also declined during key phases of Antarctica's cooling. Lower greenhouse gas concentrations reduced the planet's ability to retain heat globally, amplifying the effects of ocean isolation. But scientists still debate how different factors interacted. Some models emphasize tectonic changes. Others point more strongly toward atmospheric chemistry. Most likely, multiple systems reinforced each other simultaneously. Earth's climate rarely changes because of one isolated cause. It shifts because oceans, atmosphere, ice, geology, and biology begin interacting differently over enormous timescales. Antarctica became the place where those changes eventually crossed a threshold. And once large permanent ice sheets began forming, the process accelerated itself. Ice reflects sunlight far more effectively than forests or oceans. The more ice Antarctica gained, the more solar energy it bounced back into space, reinforcing cooling even further. In a sense, the continent began transforming into a machine that maintained its own cold. But before the full ice sheets arrived, Antarctica passed through long ages of instability. Some researchers believe glaciers advanced and retreated repeatedly before permanent freezing fully took hold. During warmer intervals, forests may briefly recover in certain regions before colder phases push them back again. Coastal ecosystems likely changed constantly as sea ice expanded seasonally into waters once dominated by marine reptiles and ancient fish communities. Entire species disappeared, not necessarily because they failed instantly, but because ecosystems became too fragmented to support long-term survival. Food chains weakened, migration patterns broke down, specialized plants lost stable habitats, and unlike sudden extinction events, slow climate transitions create a cruel kind of pressure, because survival remains technically possible for a very long time. Life keeps adapting until eventually adaptation is no longer enough. One of the strangest parts of Antarctica's freezing is how invisible it would feel on a human timescale. If people had existed there across those millions of years, no generation would wake up one morning to discover Antarctica had become ice. The transformation would hide itself inside ordinary seasons: a colder winter, a river freezing earlier than before, snow lingering deeper into spring, tiny changes accumulating beyond memory. Human civilization struggles to think in geological time because our lives are too short. Antarctica's collapse happened slowly enough to escape immediate attention, yet completely enough to erase entire worlds. And perhaps that is what makes it so haunting. This was not destruction through chaos. It was destruction through patience. Even the oceans changed personality as Antarctica cooled. The warm southern seas that once supported mosasaurs, plesiosaurs, and dense marine ecosystems gradually transformed into darker, colder waters dominated by entirely different life forms. Marine reptiles vanished long before modern Antarctic ecosystems emerged. The food chains reorganized themselves around colder conditions. Sea ice altered migration patterns and nutrient flows. Storm systems intensified. The Southern Ocean slowly became one of the harshest marine environments on Earth. Yet traces of the older world remained buried beneath the transformation. Fossil forests persisted beneath sediment layers. Ancient river systems froze beneath growing glaciers. Entire coastlines disappeared under advancing ice sheets. Antarctica became a continent layered with ghosts of previous climates. And once large-scale glaciation fully established itself around 34 million years ago during the Eocene-Oligocene transition, the shift became truly irreversible on a planetary scale. Massive ice sheets spread outward. Sea levels dropped globally as enormous quantities of water became trapped in ice. Antarctica entered a completely different climate regime from which it has never fully returned. The forests were gone. The giant reptiles were gone. The wetlands and rivers vanished beneath expanding ice. The southern continent that had once supported lush ecosystems became increasingly silent, but not immediately empty. Even during early glaciation phases, pockets of life likely survived in isolated refuges. Some scientists suspect certain coastal environments remain seasonally habitable far longer than older models assumed. Mosses, hardy plants, insects, and cold-adapted animals may have clung to shrinking ecosystems along ice-free regions. Antarctica did not die instantly. It withdrew from life step by step. And beneath the expanding ice, the older world remained trapped rather than erased. That detail matters because modern Antarctica still carries physical evidence of its former identity, hidden beneath kilometers of frozen accumulation. Subglacial mountains, buried forests, ancient lake systems, and preserved sediments all remain sealed under the ice sheet, like pieces of a previous Earth stored away from sunlight. Radar scans occasionally reveal valleys carved by rivers that have not flowed for tens of millions of years. Scientists drilling deep ice cores recover microscopic traces of vanished climates preserved layer by layer through time. Antarctica became not merely a frozen continent, but a memory vault of planetary change. And the deeper researchers look into those layers, the more uncomfortable the implications become. Because Antarctica proves how completely Earth can reinvent itself. Places humans instinctively view as permanent are temporary on geological timescales. Forests become glaciers. Warm oceans become polar deserts. Entire ecosystems disappear so thoroughly that later civilizations struggle to even imagine they once existed. Antarctica today feels eternal because ice creates the illusion of permanence. But the ice itself is part of a transformation still unfolding. Some climate researchers warn that modern warming could eventually destabilize portions of the Antarctic ice sheet again, though such changes would occur across long and complex timescales. The continent continues evolving even now. In other words, Antarctica's story may not truly be over. The frozen world humans know today is only one chapter in a much older cycle of planetary change. And buried beneath all that ice, beneath mountains entombed in darkness, and valleys untouched for millions of years, the remains of the lost southern forests still wait beneath the cold that finally consumed them. By the time Antarctica truly began surrendering to ice, the continent no longer looked like the thriving southern world it had once been. The endless forests had already started thinning across large regions. Wetlands that once supported dense ecosystems were shrinking into colder and more fragmented landscapes. Rivers froze more often during winter darkness. Storms became harsher. Entire coastlines changed shape beneath advancing glaciers and rising mountains of snow that no longer melted completely during summer. Yet life still remained there. That may be the strangest part of Antarctica's transition into a frozen continent. Even while the world around them was collapsing slowly across millions of years, certain creatures continued adapting, surviving, and moving through the last green corners of the South, long after many ecosystems had already vanished. These were not the giant reptilian worlds of the Jurassic anymore. The age of huge dinosaurs and marine reptiles had ended. Antarctica had entered a quieter phase of survival, one shaped less by dominance and more by endurance. Forests still existed in some areas during warmer intervals, but they were increasingly sparse, lower, and harder pressed by the cold. Some regions may have resembled subpolar woodlands rather than dense, prehistoric rainforests. Hardy conifers clung to valleys, protected from the worst winds. Mosses and low vegetation spread across damp ground where larger plant systems struggled. Insects adapted to colder temperatures continued cycling through short summers before disappearing into hidden shelter during long winters. The continent was becoming biologically smaller, not physically smaller, but ecologically reduced. Each passing era supported fewer large species and more specialists capable of surviving instability. Paleontologists studying Antarctic fossil records from these later periods often describe ecosystems that feel transitional, almost uncertain. Some species appear adapted for warmth, while others show signs of increasing cold tolerance. Antarctica itself was caught between identities. It was no longer the lush southern world it had once been, but it had not yet become the fully frozen desert modern humans know today. That in-between stage may have lasted millions of years. And during that time, the final survivors of green Antarctica continued living beneath skies growing colder with every geological age. Among the creatures thought to persist during these changing conditions were early birds and primitive relatives of modern waterfowl. Fossil discoveries suggest Antarctic coastlands and wetlands still supported avian life capable of navigating harsh seasonal environments. Birds may actually have possessed advantages many older reptilian lineages lacked. Feathers provided insulation. Migration offered escape routes. Warm-blooded metabolism allowed more flexibility during long, cold periods. Antarctica's worsening climate may have accelerated the rise of creatures biologically suited for endurance rather than raw size. In some ways, the continent itself selected for resilience. Smaller animals with adaptable diets, flexible behavior, and better thermal regulation gradually replaced ecosystems once dominated by giant reptiles. Mammals also began appearing more prominently in the southern world during these later ages. Not the large mammals humans recognize today, but smaller ancestral forms capable of surviving changing conditions. Some researchers believe marsupial relatives once moved across Antarctica while the continent still maintained land connections to South America and Australia. Fossil evidence discovered in Antarctic sediments hints at a southern migration network linking distant ecosystems long before oceans fully separated them. That possibility changes Antarctica's role in evolutionary history dramatically. Rather than functioning merely as an isolated dead end, Antarctica may once have served as a biological bridge connecting entire branches of life across the southern hemisphere. Animals could move gradually through forest corridors stretching between continents now divided by freezing oceans. The continent that eventually became Earth's most isolated environment may once have been one of its great crossroads. But as temperatures declined, those pathways narrowed and eventually disappeared. Forests fragmented into isolated refuges. Wetlands shrank beneath advancing frost. Food chains became increasingly unstable. The creatures surviving there faced a problem larger than cold itself. They were losing connected ecosystems. And ecosystems survive through complexity. Once enough species disappear, entire systems begin weakening in ways difficult to reverse. Pollinators vanish. Prey populations collapse. Migration routes fail. Rivers change course beneath glacial pressure. Antarctica's final green ecosystems likely became quieter over time, not because individual animals suddenly died, but because fewer species remained to fill ecological roles once occupied by entire communities. There is something deeply melancholic about imagining those last surviving Antarctic forests. Not dramatic jungles roaring with dinosaurs, but isolated valleys of fading life surrounded by growing cold. Dark evergreen trees standing beneath skies heavy with snow clouds, while freezing winds move across wetlands already turning to ice. Small animals moving carefully through undergrowth during brief summers that never feel warm enough anymore. Some scientists believe Antarctica may have experienced repeated cycles of temporary recovery during warmer climate fluctuations before freezing intensified again. If true, certain ecosystems may have expanded briefly, only to collapse once more during colder phases. life kept trying to reclaim the continent, even as planetary systems pushed against it. And because these changes unfolded so slowly, evolution itself continued adapting alongside the collapse. Some Antarctic organisms may have developed remarkable seasonal survival strategies before disappearing entirely from Earth. Certain insects perhaps entered long dormant states during winter darkness. Plants may have evolved highly specialized growth cycles, synchronized with narrow windows of summer light. Coastal animals likely depended increasingly on marine food chains as terrestrial ecosystems weakened. The final green Antarctica was not static decline. It was a desperate biological improvisation unfolding across geological time. Yet, despite those adaptations, the continent kept getting colder. Ice advanced farther each year. Glaciers carved through valleys where forests once stood. Snow accumulated faster than it melted. The southern ocean surrounding Antarctica became increasingly hostile as colder currents strengthened and sea ice expanded seasonally. Marine ecosystems shifted toward species capable of surviving near freezing water. Many older, warm-adapted lineages disappeared completely. And perhaps most importantly, Antarctica became more isolated from the rest of the world. Isolation changes evolution profoundly. Once permanent ice and cold oceans cut Antarctica off effectively, species trapped there faced shrinking options. Migration became impossible. Recolonization from warmer continents slowed dramatically. The southern continent transformed from a living bridge into a biological prison. Some researchers believe isolated refuges may have survived along certain Antarctic coastlines far longer than previously assumed, particularly during warmer intervals before full glaciation dominated the continent. There are ongoing scientific debates about exactly how much life persisted and for how long. Fossil evidence remains incomplete because most of Antarctica's ancient landscapes are buried beneath kilometers of ice. But every new discovery seems to push the timeline of survivable ecosystems slightly farther into the frozen age than older models predicted. Antarctica repeatedly reveals that life clings to possibility longer than expected. Even now, modern Antarctica supports microbial ecosystems beneath ice, hidden lakes sealed from sunlight for millions of years, and hardy organisms surviving conditions once thought nearly sterile. That persistence makes the continent feel strangely alive despite its hostility. It also raises uncomfortable questions about the final survivors of ancient Antarctica. What did the last forests actually look like? How quiet did the continent become before the ice fully won? Did isolated pockets of vegetation survive in hidden valleys while glaciers spread around them? Were there species unique to Antarctica's final green age that disappeared without leaving enough fossils for humans to ever know they existed? Those questions linger partly because Antarctica hides evidence so effectively. The ice sheet acts like both a tomb and a vault. Entire ecosystems remain buried beneath it, preserved beyond direct reach. In some exposed mountain regions, scientists have discovered fossilized wood and leaf imprints, proving forests survived farther into Antarctica's cooling history than once believed. Each discovery adds another layer to the story. The continent did not transform cleanly from jungle to glacier. It passed through long ages of ecological uncertainty, where fragments of the old world resisted extinction against overwhelming planetary change. And perhaps the most haunting detail is that those final survivors lived without knowing they represented the end of anything. A bird feeding along a cold Antarctic shoreline could not understand that entire ecosystems had already vanished northward. A shrinking forest could not recognize itself as one of the last of its kind. Antarctica's ancient life disappeared gradually enough that extinction arrived almost invisibly inside ordinary seasons. One winter slightly colder than the last. One summer slightly shorter. One migration route blocked permanently by ice. Then, eventually, after millions of years of retreat, the green world was gone. Forests disappeared beneath glaciers. Rivers froze beneath ice sheets. The final survivors either adapted into new forms elsewhere or vanished entirely from Earth. Antarctica became silent in a way it had never been before. But deep beneath the growing ice, the remains of those lost ecosystems still endured. Roots trapped in frozen sediment, pollen buried in ancient rock layers, fragments of creatures that once walked through forests under dim southern sunlight. And hidden beneath all that ice, Antarctica continued preserving clues about worlds scientists still do not fully understand. Modern Antarctica looks empty from above, endless white stretching toward the horizon. Wind carving patterns through snowfields that seem untouched by history itself. But that emptiness is deceptive. Beneath the ice lies one of the least understood landscapes on Earth. A buried world so isolated and difficult to reach that scientists still cannot fully map what exists underneath it. In some places, the Antarctic ice sheet is more than 2 miles thick. Entire mountain ranges disappear beneath it. Valleys larger than American states remain sealed in darkness. Rivers that vanished millions of years ago are still preserved beneath frozen sediment. Antarctica did not simply freeze over. It entombed its past. And every few years, new discoveries reveal that the hidden continent below the ice is far stranger than researchers once imagined. One of the first shocks came when radar surveys began revealing massive subglacial mountain ranges buried beneath the ice sheet. The Gamburtsev Mountains, hidden deep beneath East Antarctica, are roughly the size of the European Alps. Yet no human being has ever seen them directly. They sit entirely trapped below thousands of feet of ice, untouched by sunlight for millions of years. Their existence remained unknown until the 20th century because Antarctica conceals its geography so completely that entire continental-scale features can remain invisible. That realization changes the emotional scale of the continent immediately. Antarctica is not just ice sitting on top of land. It is a hidden world sealed beneath a frozen shell. And because the ice formed gradually over immense spans of time, pieces of ancient Antarctica may remain preserved below it in astonishing detail. Some scientists compare parts of the continent to a giant freezer storing fragments of Earth's earlier climates. Beneath the ice are ancient lake systems, isolated from the surface for extraordinary lengths of time. Lake Vostok, one of the most famous examples, sits trapped beneath nearly 2.5 miles of ice and may have remained sealed for millions of years. The lake itself is enormous, stretching over 150 miles long beneath the frozen surface. What makes it so fascinating is not simply its size, but the possibility that isolated ecosystems may survive there even now. Scientists remain cautious because contamination risks make exploration extremely delicate. But microbial life appears capable of surviving in environments once thought impossible. If organisms exist in such lakes, they would have evolved in complete darkness, under crushing pressure, separated from the outside world across timescales almost difficult to comprehend. Antarctica constantly forces scientists to rethink the limits of survival. And those lakes may only represent a fraction of what remains hidden. Radar imaging has revealed hundreds of subglacial lakes beneath Antarctica, linked in some cases by slow-moving water systems deep under the ice sheet. Some researchers suspect these hidden networks may influence glacier movement itself, lubricating sections of the ice from below. Others wonder whether ancient sediments inside these lakes preserve climate records stretching back millions of years. Every new discovery beneath Antarctica creates more questions than answers, because the continent remains so physically inaccessible. Even modern technology struggles against the environment there. Drilling projects require enormous logistical effort. Equipment freezes. Storms shut down operations. Temperatures destroy machinery. Antarctica almost behaves like a place resisting investigation. And perhaps nowhere is that resistance more intriguing than in the fossil evidence occasionally emerging from beneath retreating ice or exposed mountain regions. In some areas, scientists have uncovered fossilized forests astonishingly well preserved despite their age. Ancient tree roots remain embedded in soil that once supported ecosystems near the South Pole. Pollen grains survive trapped inside sediments, allowing researchers to reconstruct vanished climates in remarkable detail. Microscopic traces of ancient vegetation reveal forests once covered regions now buried beneath permanent ice. These discoveries matter because they prove Antarctica's transformation was even more dramatic than earlier generations believed. The continent did not merely cool. Entire worlds disappeared beneath it. And the deeper researchers examine buried sediments, the more it becomes clear that Antarctica still contains enormous amounts of undiscovered paleontological information. There may be species preserved there that science has never seen. Entire ecosystems may remain trapped beneath ice sheets where no human has drilled deeply enough to reach them. Some paleontologists suspect Antarctica's fossil record could radically reshape understanding of prehistoric southern ecosystems if larger regions ever become accessible. But accessibility itself is part of the mystery. Most of Antarctica's buried past remains unreachable. In some places, scientists know ancient landscapes exist beneath the ice because radar can detect valleys, river systems, and sediment layers below. Yet physically reaching them would require drilling through miles of frozen accumulation in one of the harshest environments on Earth. That means Antarctica preserves uncertainty unusually well. Other continents expose their ancient history gradually through erosion and human development. Antarctica hides it almost completely. And because the hidden continent remained isolated for so long, speculation naturally grows around what else might still exist below the surface. Some ideas remain scientifically grounded, others drift into exaggeration. Antarctica has attracted myths and conspiracy theories for decades, precisely because it feels unknowable. Stories about lost civilizations, hidden structures, or secret worlds beneath the ice circulate constantly online. There is no credible scientific evidence supporting those sensational claims, but the reason such stories persist is understandable. Antarctica genuinely does contain buried landscapes humans have never directly explored. It genuinely preserves ecosystems from ancient Earth beneath enormous ice sheets, and radar scans occasionally reveal formations strange enough to fuel endless speculation, until further analysis explains them through geology or glaciology. The real scientific mysteries are already compelling enough without inventing fantasy. For example, researchers studying Antarctic sediments have discovered evidence suggesting parts of the continent may once have supported temperate rainforests far more recently than older climate models predicted. Some findings imply regions of Antarctica remain surprisingly warm during periods previously assumed to be fully frozen. That possibility complicates the timeline of Antarctica's collapse and raises difficult questions about climate sensitivity on Earth. How quickly can planetary systems shift between radically different states? How stable are ice sheets over geological timescales? Antarctica's buried history may contain answers that matter not only for understanding the past, but also for understanding Earth's future. Ice cores extracted from the continent already preserve atmospheric records stretching back hundreds of thousands of years. Tiny bubbles trapped inside ancient ice allow scientists to study past carbon dioxide levels, temperature patterns, volcanic eruptions, and climate cycles with incredible precision. In a sense, Antarctica functions as both fossil archive and climate memory system simultaneously. The continent records the history of worlds that no longer exist, and sometimes those records reveal uncomfortable patterns. Climate changes that seem impossible within human experience become visible across deeper timescales. Ice expands, ice collapses, oceans rise, forests vanish. Antarctica demonstrates that Earth's environments are not fixed states, but moving phases in a planetary process far larger than civilization itself. Yet, despite all modern science, huge portions of Antarctica remain unexplored even now. Beneath the ice are valleys no human has entered, sediments no drill has reached, and ecosystems no microscope has examined. Some scientists suspect microbial life may exist beneath glaciers in forms adapted to darkness and cold so extreme they resemble potential extraterrestrial organisms more than familiar Earth life. That possibility is one reason NASA and other space agencies study Antarctica intensely. The continent may provide clues about how life could survive beneath the icy crusts of moons like Europa or Enceladus. In other words, Antarctica's buried mysteries may help answer questions extending far beyond Earth itself. And perhaps the most unsettling realization is how temporary the ice sheet may ultimately be. Antarctica feels eternal because humans have only known it as frozen wilderness. But the continent has worn many different faces across geological time. Forests once grew there. Rivers once flowed there. Giant reptiles once hunted along its coasts. Which means The hidden world beneath the ice is not merely ancient. It is evidence that Antarctica has transformed repeatedly before. Some climate researchers warn that portions of the modern ice sheet are already destabilizing under current warming trends, though the full consequences remain uncertain and unfold across complex timescales. Still, the idea lingers quietly beneath all Antarctic research. The continent humans think they know is only one temporary version of Antarctica. The buried landscapes below the ice belong to older worlds, waiting silently in darkness. And every time scientists drill deeper into the frozen continent, Antarctica reveals another fragment of a forgotten Earth that was never truly gone, only hidden. There are moments in Antarctica when Earth stops feeling familiar, not because of the cold alone, but because the continent seems to operate by rules that belong somewhere else entirely. The sky behaves strangely there. Sound travels differently across the ice. Light can linger for months without darkness, or vanish for entire seasons beneath endless polar night. In some regions, winds descend from the interior at hurricane force, carrying ice crystals so fine they resemble smoke moving across the ground. Beneath the frozen surface are lakes sealed away from sunlight for millions of years, ecosystems trapped under pressure and darkness, in complete isolation from the rest of the planet. Modern scientists sometimes describe parts of Antarctica less like a normal continent and more like an analog for alien worlds. And the deeper researchers study its ancient history, the more unsettling that comparison becomes. Because prehistoric Antarctica may not only have looked unlike modern Earth, at certain points in its past, it may have resembled environments humans normally imagine existing on distant planets or icy moons far beyond our solar system. One reason Antarctica feels so alien is because it constantly pushes life toward extremes. Even during its ancient green eras, the continent experienced environmental conditions few modern ecosystems endure. Months of continuous daylight, followed by months of darkness, created biological pressures almost impossible to visualize through ordinary human experience. Imagine forests growing beneath a sun that never truly sets, then surviving through seasons where twilight barely appears for weeks. Imagine animals navigating landscapes where the sky itself behaves unpredictably, where circadian rhythms collapse, and where the difference between day and night begins to lose meaning. Some scientists believe these extreme light cycles may have shaped ancient Antarctic evolution in unusual ways, selecting for flexible biological clocks and survival strategies unlike those in more stable climates. In that sense, even warm Antarctica may already have been psychologically and biologically strange long before the ice arrived. But once the continent froze, the alien comparison intensified dramatically. Modern Antarctica contains some of the harshest environmental conditions on Earth. Temperatures fall low enough to freeze exposed skin in minutes. Entire valleys remain nearly devoid of visible life. In certain regions, humidity is so low that Antarctica technically qualifies as a desert, despite being covered in ice. Yet life still persists there. Microbial ecosystems survive inside rocks, beneath glaciers, and within subglacial lakes buried under miles of frozen accumulation. Some organisms endure darkness, pressure, salinity, and cold, once believed incompatible with life itself. That ability to survive at the edge of possibility is exactly why NASA and other space agencies study Antarctica so intensely. Because if life can exist beneath Antarctic ice, perhaps it could survive elsewhere too. One of the strongest comparisons scientists make involves Jupiter's moon Europa, a frozen world covered by thick ice believed to conceal a global ocean beneath its surface. Europa receives almost no sunlight capable of supporting Earth-like ecosystems at the surface. Temperatures are brutally cold. Yet, tidal forces generated by Jupiter may create internal heat deep below the ice, potentially allowing liquid water and perhaps even simple life to exist beneath the frozen crust. Antarctica offers one of the closest natural analogs humans can study directly. Subglacial lakes, such as Lake Vostok, remain isolated beneath Antarctic ice under crushing pressure and complete darkness, conditions that partially resemble environments theorized beneath Europa's surface. If microbial ecosystems survive in those Antarctic lakes, it strengthens the argument that life may adapt to environments far more extreme than previously imagined. In other words, Antarctica quietly changes the definition of what a habitable world might look like. Ancient Antarctica complicates the picture even further because it demonstrates how dramatically a planet can transform over time. A continent once covered in forests, rivers, and giant reptiles became one of the coldest places in the solar system without leaving Earth at all. That transition matters because scientists increasingly suspect many planets and moons beyond Earth may also experience radical climate shifts across geological time. Frozen worlds may not always have been frozen. Warm worlds may eventually become hostile. Antarctica preserves evidence that planetary identity itself is unstable. And perhaps that instability is more common across the universe than humans once believed. There is also something visually extraterrestrial about Antarctica's buried landscapes. Radar scans reveal mountain ranges hidden beneath ice sheets thicker than skyscrapers are tall. Subglacial rivers move silently through darkness no sunlight has touched for millions of years. Strange blood-red outflows occasionally emerge from glaciers where iron-rich water oxidizes against the air, creating scenes that look almost impossible to belong to Earth. Even Antarctica's silence feels unusual. In many regions, the continent lacks the familiar biological background noise humans unconsciously expect. No insects, no forests moving in the wind, no distant animals calling through the night. Just ice, wind, and vast empty distances beneath skies that sometimes glow with auroras, moving like electrical storms across space itself. Scientists stationed in Antarctica often describe feeling psychologically detached from ordinary reality after extended periods there. The continent alters human perception because the environment removes so many familiar reference points. Scale becomes difficult to judge. Time feels distorted during endless daylight or darkness. Isolation deepens beneath the silence. Antarctica does not merely look alien, it can make people feel alien too. And that emotional atmosphere may help explain why the continent appears so frequently in science fiction and speculative visions of other worlds. Yet, the most fascinating possibility is not that Antarctica resembles alien planets today. It is that ancient Antarctica may have supported forms of adaptation and survival that hint at how life elsewhere in the universe could evolve under unusual environmental conditions. Consider the organisms that once survived Antarctica's ancient polar forests. They endured extreme seasonal light cycles, unstable climates, and long periods of environmental stress. Some adapted to darkness lasting months. Others survived repeated climate fluctuations across geological time. Life on Earth repeatedly demonstrates an ability to improvise under conditions that initially seem impossible. That realization forces a subtle but profound shift in perspective. Perhaps habitable worlds do not need to resemble Earth's modern tempered environments as closely as scientists once assumed. Perhaps life becomes possible anywhere chemistry, energy, and time interact long enough under stable enough conditions. Antarctica keeps pushing that boundary outward. Even today, researchers continue discovering microorganisms surviving in Antarctic environments previously considered nearly sterile. Some bacteria remain active within deep ice. Others endure inside highly saline subglacial water systems where temperatures remain below freezing, yet liquid water persists because of pressure and chemistry. These ecosystems survive with minimal sunlight and limited nutrients, relying on chemical energy sources instead. Similar processes may theoretically support life beneath the ice-covered oceans of distant moons. Antarctica transforms those possibilities from pure speculation into something grounded in observable biology. But the continent also carries a darker implication. Alien worlds are often imagined as lifeless because they appear frozen and hostile from the outside. Antarctica reminds scientists how deceptive appearances can be. Beneath its ice may exist active ecosystems, preserved ancient landscapes, and biological systems humans still barely understand. That raises difficult questions about distant planets as well. How many seemingly dead worlds might conceal hidden environments beneath their surfaces? How much of the universe's biology could exist beyond immediate visibility? Antarctica becomes a kind of rehearsal for learning how to search for invisible life. And perhaps the most unsettling aspect of all is realizing that Earth itself once produced environments more alien than many humans instinctively imagined possible here. Prehistoric Antarctica combined endless polar light, giant reptilian ecosystems, volcanic landscapes, warm forests, seasonal darkness, and eventually planetary-scale glaciation, all within the same continent across deep time. Few fictional planets undergo transformations that dramatic. Antarctica did it naturally, which means the line between Earth and alien world may be thinner than humans prefer to believe. Our planet already contains environments that feel detached from ordinary human experience. Antarctica simply happens to preserve them more clearly than most places because ice freezes history in place. Deep beneath the continent, ancient ecosystems remain trapped under frozen darkness, like memories from another planet hidden inside our own. And as researchers continue drilling deeper into Antarctic ice and studying the organisms surviving there now, the continent keeps delivering the same quiet message. Life may be stranger, tougher, and more adaptable than humanity has yet fully understood. If all the ice covering Antarctica disappeared, the world beneath it would not emerge as a flat, frozen wasteland. It would look like the exposed remains of an entirely different planet. Mountain ranges would rise from the center of the continent, where humans today see only endless white. Vast valleys carved by ancient rivers would reappear after lying buried for millions of years. Deep basins, larger than entire countries, would fill with seawater. Hidden lakes, sealed beneath the ice, would finally open to the atmosphere again. And scattered across that exposed landscape would be traces of ecosystems that vanished long before human civilization began. Antarctica without ice is difficult to imagine because modern humans have never seen it. The ice sheet is so enormous, so permanent seeming, that the frozen continent feels less like a temporary climate state and more like part of Earth's original design. But geologically, the ice itself is relatively young. Remove it, and Antarctica would reveal a landscape shaped by forests, rivers, tectonic collisions, volcanic activity, and ancient climates stretching deep into Earth's past. Some scientists believe portions of the hidden continent would resemble rugged northern Canada or Patagonia, while others might look almost Martian. Dry valleys, exposed rock, and wind-carved terrain untouched by direct sunlight for geological ages. In certain regions, mountain peaks already break through the ice today. These are called nunataks, isolated rocky summits rising above the frozen surface like islands in a white ocean. They offer a glimpse of the continent buried below. Jagged black rock. Ancient formations older than most visible landscapes elsewhere on Earth. Valleys that continue downward beneath miles of ice. Antarctica's hidden geography is far more dramatic than many people realize because the weight of the ice conceals almost all visible elevation. Beneath East Antarctica alone lie mountain systems comparable in scale to the Alps. Some valleys descend far below sea level, held dry only because ice fills them. If the ice vanished completely, seawater would likely flood portions of the continent, transforming Antarctica into a fragmented archipelago surrounded by deep inland seas. The map of the continent itself would change entirely. But the physical landscape is only part of the story. The greater mystery involves what the ice has preserved. Antarctica's ice sheet acts like a giant protective seal over environments untouched for millions of years. Beneath it lie sediments from ancient forests, traces of prehistoric river systems, fossil pollen, microbial ecosystems, and perhaps entire biological records still undiscovered. If the ice disappeared gradually over geological time, scientists might gain direct access to parts of Earth's past that currently remain almost unreachable. Fossil beds hidden beneath glaciers could emerge into the open air. Ancient coastlines might reveal ecosystems from warmer climatic eras. Entire chapters of Earth's evolutionary history could suddenly become visible again. Some researchers suspect Antarctica may contain fossils unlike anything yet discovered elsewhere because the continent followed such unusual environmental pathways during its long isolation. species adapted to polar forests, seasonal darkness, and transitional climates may still remain buried beneath the ice, waiting to be uncovered. There is something deeply eerie about that possibility. Entire ecosystems may still exist physically beneath Antarctica, not alive, but preserved. Forest roots frozen into ancient soil, leaves trapped in sediment, bones resting inside valleys no sunlight has touched since before humans evolved. Antarctica is not empty beneath the ice. It is hidden. And if that hidden world returned to the surface, it would force humanity to confront how temporary Earth's current appearance really is. Because Antarctica without ice is not a hypothetical fantasy. It is evidence of what the continent used to be. Scientists know forests once existed there. Rivers once flowed there. Dinosaurs once moved across its valleys. The frozen world humans recognize today is only one phase in a much longer cycle. That realization carries uncomfortable implications for the future as well. Modern climate research shows parts of Antarctica's ice sheet are already changing. Certain glaciers have begun retreating. Ice shelves fracture and collapse. Warmer ocean water moves beneath vulnerable coastal ice in some regions. Scientists remain careful about predicting exact long-term outcomes because ice systems behave in extremely complex ways, but the broader concern is real. Antarctica is not as permanently frozen as it appears, and even partial melting would reshape the world dramatically. If all Antarctic ice melted completely, a scenario that would require extremely long timescales and conditions far beyond near-term modern projections, global sea levels could rise by roughly 190 feet. Entire coastlines would disappear beneath the ocean. Cities such as New York, Miami, Shanghai, London, and countless others would be transformed or submerged. But beyond the human consequences, Antarctica itself would become something entirely unfamiliar. The continent would slowly emerge from beneath the ice, like a buried world resurfacing after millions of years. At first, the landscape would likely appear barren and unstable. Newly exposed rock lacks developed soil. Harsh winds would dominate open terrain. But over time, life would return. Microbial colonies would spread first. Mosses and hardy plants might establish themselves along coastlines and warmer valleys. Birds and marine life would expand into newly available habitats. Given enough time and suitable climate conditions, parts of Antarctica could theoretically support forests again someday. Not the same forests that vanished millions of years ago, but new ecosystems shaped by whatever climate existed then. In a strange sense, Antarctica's past and future mirror each other. The continent has already transformed from green world to frozen desert once before, which means transformation itself may be Antarctica's most permanent feature. There is also the question of what hidden biological systems might awaken if the ice retreated significantly. Subglacial lakes, isolated for millions of years, could become exposed. Ancient microbes preserved in ice or sediment might interact with modern ecosystems for the first time in unimaginable stretches of time. Scientists approach such possibilities cautiously because much remains uncertain. But Antarctica contains biological archives unlike almost anywhere else on Earth. The continent preserves ancient atmospheric records inside ice bubbles, dormant microorganisms inside deep frozen layers, and climate history embedded across stacked glacial deposits. Melting ice would not simply reveal rock, it would expose stored planetary memory. Some scientists even worry that rapid destabilization of ancient frozen systems could create unpredictable ecological consequences, although the scale and likelihood of such events remain debated. Antarctica reminds researchers constantly that Earth's systems are interconnected in ways humans still do not fully understand. Yet, beyond the scientific implications, there is something emotionally powerful about imagining Antarctica without ice. The continent today feels timeless because humans only know it as frozen silence. But beneath that silence lies proof that Earth can reinvent itself completely. A person standing in Antarctica millions of years ago would not recognize the modern continent, and perhaps millions of years from now, future life forms may not recognize the Antarctica humans know today either. Ice creates the illusion of permanence because it appears ancient and immovable. But Antarctica's history reveals that even the largest ice sheets are temporary chapters in a much larger planetary story. That realization changes the way the continent feels emotionally. Antarctica stops seeming like the end of the Earth and starts feeling more like a transition point between different versions of Earth itself. Beneath the ice are traces of lost forests and vanished oceans. Above the ice are warnings about climates still capable of changing. The continent exists between memory and possibility at the same time. And perhaps the strangest part is realizing that Antarctica may already contain the blueprint for its own future, hidden inside its buried past. Forests once grew there under warmer skies. Rivers once crossed valleys, now sealed beneath glaciers. Life adapted there before the ice arrived. If the frozen shell ever disappeared again, even across immense geological timescales, the continent would not become a blank world. It would become visible once more, a forgotten landscape returning slowly from beneath the cold that buried it. At the bottom of the Earth, beneath miles of frozen silence, an older world still exists. Not alive in the way forests or oceans are alive, but present, waiting. Buried beneath layers of ice so ancient that some of it fell as snow before human civilization existed at all. And somewhere below that frozen weight are the remains of rivers that no longer flow, coastlines erased from maps millions of years ago, forests that once moved in warm polar winds, and creatures that lived entire lives under skies modern humans would barely recognize. Antarctica today feels eternal because ice has a way of hiding time. When people look across the continent, they see permanence, endless white stretching beyond the horizon, storms moving through emptiness, a landscape that appears untouched by history. But Antarctica is not untouched by history. It is history compressed beneath ice. Every glacier covering the continent is layered over older worlds the same way sediment buries fossils. The frozen surface humans know today is only the newest version of Antarctica, resting above countless forgotten versions that came before it. And perhaps that is what makes the continent feel so haunting compared to anywhere else on Earth. Antarctica is not simply a place where life struggles to survive. It is a place where entire worlds disappeared almost completely. There was once a time when rain fell there instead of snow. Rivers cut through valleys, now trapped beneath glaciers. Dense forests spread across land, now buried under ice, thicker than skyscrapers are tall. Giant reptiles moved through wetlands, while strange southern sunlight lingered near the horizon for weeks without darkness. The oceans surrounding the continent once carried massive predators through waters far warmer than the freezing seas of today. And all of it vanished slowly enough that the transformation itself became almost invisible. That may be the most unsettling part of Antarctica's story. The continent was not destroyed suddenly. It faded, forest by forest, coastline by coastline, species by species. The world beneath the ice did not collapse in one catastrophic moment. It retreated gradually into geological memory. Sometimes, when scientists study Antarctica, they describe the ice sheet almost like a giant archive. Each layer preserves fragments of older climates and atmospheres. Tiny air bubbles trapped inside deep ice still contain traces of Earth's ancient skies. Sediments beneath glaciers preserve pollen from forests that disappeared millions of years ago. Fossils emerge from exposed rock, proving creatures once survived in environments modern humans would consider impossible. Antarctica keeps revealing the same truth repeatedly. Earth is far less stable than it appears. Oceans move, continents drift, climates transform. Entire ecosystems vanish so thoroughly that later civilizations struggle to imagine they ever existed. Antarctica forces humans to confront time on scales almost beyond emotional comprehension. Human history feels enormous to us. Ancient empires rise and collapse. Languages disappear. Entire civilizations vanish into myth. Yet Antarctica's forests lived and died across timescales so vast that human civilization occupies only a tiny fraction of the continent's frozen age. The forests beneath Antarctica's ice are older than humanity itself by an almost unimaginable margin. And still, in geological terms, even those forests were temporary. That realization changes the emotional meaning of extinction. People often imagine extinction as sudden destruction, fire, impact, violence, apocalypse. Antarctica tells a different story. Here, extinction happened quietly. Seasons became colder. Ice lasted longer each year. Rivers slowed beneath freezing temperatures. Migration routes disappeared. Ecosystems fragmented gradually until eventually only fragments remained. The world ended there, not through explosion, but through patience. And because the process unfolded across millions of years, no creature living through it would fully understand what was happening. Imagine being among the last forests of Antarctica without knowing you are witnessing the end of your world. Snow arrives slightly earlier than it once did. Summers feel shorter. Certain birds stop returning. Wetlands freeze more deeply every winter. Yet life continues, adapting season by season, generation by generation, while the larger collapse remains too slow to perceive directly. Antarctica's ancient ecosystems disappeared inside ordinary time. That subtlety makes the story feel strangely human despite its immense scale. Civilizations disappear that way too sometimes, not all at once, but slowly enough that people inside them mistake decline for normal life. Antarctica carries another unsettling lesson as well. The frozen continent humans know today is not permanent either. Modern science increasingly suggests that Earth's climate systems remain dynamic even now. Glaciers advance and retreat. Ice shelves fracture. Oceans warm and cool across long cycles. Researchers continue debating exactly how Antarctica will change in the future and over what timescales. But the broader reality is unavoidable. The continent is still evolving. The ice sheet itself is not eternal, which means the buried world beneath Antarctica may not remain hidden forever. Someday, whether millions of years from now or through slower natural cycles beyond human civilization itself, parts of the continent could transform again. Forests may eventually return to regions now trapped beneath permanent ice. Rivers may flow again through valleys untouched by sunlight for geological ages. Antarctica has already changed identities multiple times across Earth's history. There is no reason to believe it has reached its final form. And perhaps that is why the continent feels almost philosophical, in a way few places on Earth do. Antarctica strips away the illusion that environments remain fixed. It reveals Earth as something fluid and restless beneath the surface, a world constantly rebuilding itself through deep time, while living creatures briefly occupy temporary climates before disappearing again. Even the term natural world begins feeling unstable there. Which version of Antarctica is natural? The warm forest continent? The dinosaur world? The frozen desert? The answer, strangely, may be all of them. Antarctica has been many different worlds already. The ice simply hides those earlier versions beneath silence. There is also something deeply lonely about Antarctica's buried past. The forests are gone. The rivers are gone. The giant reptiles vanished long ago. Entire ecosystems disappeared without witnesses because humans arrived unimaginably late to the story. No human eyes ever saw those Antarctic forests directly. No civilization recorded the final winters of the southern dinosaurs. The entire transformation occurred in darkness, long before memory existed. Yet traces remain: a fossilized root, a pollen grain, a buried valley beneath the ice, tiny fragments proving those worlds were real. Sometimes that feels almost harder to accept than total disappearance would. Antarctica preserved enough evidence to remind humanity of what vanished, but not enough to fully reconstruct it. The continent leaves gaps, mysteries, missing pieces hidden beneath the frozen surface, and perhaps those missing pieces are part of what keeps Antarctica so compelling scientifically and emotionally. Every discovery there feels incomplete by nature. Scientists uncover ancient forests, but not the full ecosystems surrounding them. They find fossilized creatures, but not the complete food webs they lived within. Radar reveals hidden mountains, but not the landscapes between them. Antarctica constantly suggests realities larger than the evidence available. It feels like a continent built from fragments of lost worlds. And beneath all of that ice, time continues accumulating silently. Snow falls, layers compress. Glaciers move slowly across buried valleys. The frozen continent keeps sealing itself over, preserving histories humans may never fully uncover. Yet, even with all its silence, Antarctica tells one clear story. No world lasts forever. Not forests, not oceans, not ice. Earth changes too slowly for human instincts to notice easily. But over deep time, even the largest ecosystems become temporary arrangements between geology, climate, and chance. Antarctica simply makes that truth impossible to ignore, because the contrast is so extreme. A continent that once supported forests and giant predators now stands as one of the coldest and emptiest places on Earth. And somewhere beneath the frozen surface tonight, below the storms and endless ice fields, the remains of those ancient worlds still wait in darkness, exactly where the planet left them when the cold finally arrived. Thanks for spending this time exploring the lost world beneath Antarctica with me tonight. If you enjoyed the journey, don't forget to subscribe to Sleepy Earth channel for more relaxing ancient mysteries and forgotten worlds. Leave a comment below telling me what topic you'd like me to explore next. Wherever you are tonight, I wish you good luck, good health, and a peaceful sleep.